Hello, guys. My name is Desmond, and I welcome you to my lesson for today. Ladies and gentlemen, obviously, as indicated in the group, in today's lesson, we'll be looking at functions. So, this is a masterclass that I'll be doing for today, where I'm expecting all grade 10s, 11, and 12s to form part of today's lesson. Good people, before I start with the business of the day, let's just do a mic test where everyone unmute their mic. It's either you greet or whatever, then you mute your mic. In that way, I'll be able to know that all is clear. You are able to see over there, and again, everyone is good.
Hi.
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 Hi, say.
Okay. That was a good indication that all is in order from your side, and again, all is well on my side. So, good people, remember at all times, make sure that your mics are muted, because if you do not have your mics muted, I'm going to mute them from my side, which means until the end of this lesson, you will never be able to communicate. Timakatso Mofokeng, please make sure that your mics remain muted. So, guys, without any waste of time, I'm just going to quickly take you through all these types of functions that we've got. So, firstly, we've got a straight line, which is what we'll be looking at. So, again, we've got a parabola, which is another type of a straight line, of which I would like all of you guys in this group to be aware of what parabola is. And again, we've got what we call a hyperbola. It doesn't end there. We also have exponential. So in today's lesson, we might need to focus on two functions, namely straight line and parabola. If it happens that we still have some time, we can still go for hyperbola and exponential. Otherwise, if we fail to cover everything today, then in tomorrow's lesson, we'll do the remaining parts from Wednesday until the end of the week. What we'll be doing is to solve exam type of questions. So, good people, just make sure that you do not miss any of my lessons. So, guys, for the last time, I'm begging you to just leave your mics muted so that we do not get disturbed. Okay, so let me remove that and say, let's have a look at what we call a straight line. So remember, guys, just make sure that you don't have a list of participants or learners on your screen, because you won't be able to clearly see in that perimeter of my whiteboard. So just click on that mini screen which shows where I'm writing, so that you zoom in and you are able to see everything. So good people, remember, before you become an adult, you go through some phases. For example, let's say initially you were a baby. From being a baby, let's say you become a teenager. From becoming a teenager, then you become an adult. So let's assume that a straight line formula went through its own phases. So I just want to quickly take you through where a straight line formula started up to what you currently know, which is what probably the teacher has taught you in class. So initially, guys, a straight line formula started as something being y is equals to x. This is the start of a straight line formula. So I'm going to explain all of these phases, ladies and gentlemen. So from a straight line formula being a baby, then it grew to become a teenager. So this is how it looks like when it's a teenager. We have y is equals to mx plus c. Ladies and gentlemen, it doesn't end there. It grows to become an adult. So let's have a look at how a straight line formula looks like when it's an adult. So we've got y is equals to mx plus c. So at all times, when you are given a straight line formula, just ask yourself, at what stage is that particular formula? So it's either it's at a baby stage, at a teenager, or as an adult. So now let me firstly explain what's going on over there. So obviously it means this is simple, moderate, maybe difficult or complicated to interpret or to understand, to use or whatever. So the purpose of today's lesson is to make you understand these functions. So guys, let's have a look at how less complicated it is when it is at that stage of which in our lessons we'll refer to it as a baby. So let's say we've got let me just firstly start representing this on a Cartesian plane. Good people, what is a Cartesian plane? Always, when we talk about a Cartesian plane, we talk about the vertical line, which is well known as the y-axis. And we also have the horizontal line, which is well known as the x-axis. Very, very much important, ladies and gentlemen. So a Cartesian plane, it's more like a plate. So what do you do inside a plate, ladies and gentlemen? Inside a plate, that's where you put a wing there. That's where you put some pap there. That's where you've got some gravy there. So that means we use a plate to contain some food. Good people, we use a Cartesian plane to do what? To draw functions, which means at all times functions are drawn on a Cartesian plane. Which type of functions can be drawn on a Cartesian plane? We've got a straight line, we've got a parabola, we've got a hyperbola, we've got exponential. But in today's lesson, we'll be looking at a straight line and possibly a parabola. So for now, I'm only talking about a straight line at a baby stage. So remember, guys, a straight line is just a line which is straight. It doesn't matter whether it's straight at that angle. It doesn't matter whether it's straight at that angle. It doesn't matter straight at that angle or whichever angle. When we talk about a straight line, we just talk about a line which is straight. So it's as simple as that. So y is equals to x is just a straight line passing through the origin. Remember, ladies and gentlemen, this is a Cartesian plane. It obviously has that point which we call the origin. What is the origin? So at the origin, ladies and gentlemen, that's where x is 0 and y it's 0. So in short, that's where the y-axis intersect with the x-axis. At the point of intersection of the two axes, that's where we have what you call the origin. And at the origin, we have 0 and 0. So, good people, this is a straight line. Very, very much important, ladies and gentlemen. So, a straight line could be in that direction where it starts from maybe quadrant number 3 heading towards quadrant number 1, or from quadrant number 1 to quadrant number 3. Good people, we can also have a straight line like that. So this is now a straight line which is actually a, let's say, from quadrant number 2 to quadrant number 3. Very, very much important, ladies and gentlemen. So that means this one, it's actually from quadrant number 1 to quadrant number, let's see, 1, 2, 3. This is 2 and 4. So let me just make sure to update that so that it makes perfect sense. So by quadrant number 2 and 4, I'm simply saying it's a line that ends in that quadrant number 2 and that which is quadrant number 4. So this one is a line starting from quadrant number 1 and it also passes through to quadrant number 3. Very, very much important. Guys, every baby has got a name. Very, very much important, ladies and gentlemen. In this group, we've got Karabo. Let me see. We've got Kayiya Situba, we've got Tabise Mbanele, Dimaka Swayanda, Teva Zanda, Tando, Mr. D, Kevin, Grace, Lindokutle. We've got, let me see, who else is there? Guys, my name is Desmond. So I've got a name. Good people, functions are given names. Very, very much important, ladies and gentlemen. Very, very much. Why do we have to give these functions names? Is because when we talk about Lindokutle, we just need to specifically talk about Lindokutle. When we talk about Yaye or Taiya or Karabo, we just want to specifically talk about Karabo. So, good people, what names are given to functions? They just use a letter from A, B, C, D, E, F, G, all the way up to Z. So, in short, they use letters to give names to straight lines, parabola, hyperbola, or exponential. So, can you see we've got two straight lines? So, they normally like using these letters, guys. They would give it G, which means it's G of X. They would give it maybe H. That means we've got a graph known as H of X. They can maybe call it, let's say F, then it becomes F of X. Or maybe they can call it K, which means it's going to be a K of X. It doesn't matter which letter they use. You just need to know that the moment when they say G of X, H of X, F of X, K of X, this is a name given to a function. Very, very much important. So now let's give that one a name. Let me maybe call it H. So that means every time when we talk about H of X, we talk about that boy over there. So now, let me see. Let's now give that one a name and say this is Catuchero. So that straight line, we name that boy Catuchero. So let's say instead of saying Catuchero, because it's a longer name, let's just say this is K. Then it becomes K of X. This becomes H of X. Good people, what I'm trying to say is that H of whatever, K of whatever, G of whatever, F of whatever, don't be confused by that. It's just a name given to a straight line. Just like that vertical line is called y-axis, that horizontal line is called the x-axis. Very, very much important, ladies and gentlemen. So now, remember, guys, I've just explained to you to say, let's have a look at that function at a baby stage. So it's just a straight line. It doesn't matter at what angle. But what matters the most, you just need to be aware that for that function, it has got a positive x value there. Very, very much important. So that means for all the straight lines crossing and passing or continuing in that first quadrant and that third quadrant, they've got a positive there, then you have x over there. Then that means for the straight line functions passing through quadrant number 2 and quadrant number 4, we therefore say they've got a negative value over there. Very, very much important, ladies and gentlemen. You will understand better in terms of what we mean by that negative over there. So let me just remove that so that it doesn't confuse you guys to end up thinking we've got a plus or a minus over there. So that means for all the functions, the straight line, it doesn't matter whether it's a straight line passing through there, or wherever. There, or wherever. What you need to know is that for a straight line in that direction, we've got a positive value there. For that one, we've got a negative value over there. So I want us to quickly discuss that part at a teenager stage. So can you see, baby stage is just y is equals to x. Teenager is y is equals to mx. So let's have a look at what happens at that stage. So this m, it has got a very huge impact on the slope of a straight line straight line function. So this is what we call the gradient or the slope. So the bigger the slope or the bigger the gradient, the steeper the line. So that means if we have a bigger value there, not necessarily in terms of the sign, but let's say maybe the gradient, it's now 2. So that means that straight line will no longer be in that angle or along that line. Let's say maybe there it was 1. So if it was 1, it was like that. So now the gradient is 2. If it's 2, then it gets steeper. It gets steeper. If it's 4, it gets steeper. So when I say it gets steeper, guys, just think yourself walking from that direction and you have to now climb this straight line. Can you see? To climb this one, you can easily walk up to there. But now, if it gets steeper, think of it as a mountain. You want to now climb, it gets steeper. If that value increase, then it gets even more steeper, ladies and gentlemen. But now, if it decreases, then that means the slope becomes gentle. So in terms of that value being a negative value, the same thing can be explained. So that means it's going to be a line from the second quadrant to the fourth quadrant, but at different slopes, at different slopes, at different slopes, at different slopes, different slopes, at different. Guys, I'm releasing a song. I call it Desmond Mapiano. At different slope, at different slope, at different slope. Kong 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 kong, kong 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 kong. Guys, that was my song for the year. So, good people, what I've explained up to this point, it's the baby stage and the teenage stage. So now, please allow me to try and explain the adult stage. So can you see, at the adult stage, we have that part of the baby, We also have that part of the gradient. The only difference is there where we've got plus c. Good people, that c, it shouldn't scare you. So that c, it actually talks about a straight line. Remember, all of this, they are actually passing through the origin. So the moment we start having our general formula with a plus c, that means this straight line formula, it shifts vertically either up or down. So this is a straight line passing through the origin. So if I say plus 2, then it means I'm going up by 2. Why up? Because I'm saying plus 2. So that means it's going to be 1, 2. So if there you've got positive 1, positive 2, that means that straight line is no longer passing through the origin, but is passing through point number 2 over there. Very, very much important, ladies and gentlemen. So if there I've got plus 5, that means that straight line which was passing through the origin is now being shifted 1, 2, 3, 4, 5 vertically upwards by 5 units. Massively important, ladies. So now, what if it's a minus? Good people, it's not that much complicated. What it means is that same function passing through the origin, it moves 1, 2, 3, 4, for example, if it's minus 4 there, which means it is going to pass through that point over there. Guys, same applies for that straight line with a negative gradient. So if, for example, we now have let's say minus 4 hang up, put it on do not disturb. Okay, so guys, I was saying if we've got a negative gradient in that direction, so this can be moved either upwards or downwards. So that means the c value influence the vertical shift, which could be the upward or the downwards. It all depends on what that value is, and again, if it's a positive or a negative. Let's say it's negative 4. So that means this same straight line is going to move 1, 2, 3, 4 units downwards. So you are going to have something similar to that. If it's been moved maybe upwards by 3 units, then it was going to move from there by 1, 2, 3. Then it's going to pass somewhere there. Very, very much important, ladies and gentlemen. So now that I've explained all of this, let me quickly remove all of these and explain exactly what I mean by all that I've explained, just so that you guys are not being confused. So let me see. Let's say we are given y is equals to, let's say, x, and again we are given y is equals to, let's say, 2x. Y is equals to, let's say, negative 4x. Y is equals to, let me say, 3x plus 2. And the last one being y is equals to, let's say, negative 2x minus 3. So what I want to quickly do, guys, is just to give you an idea of exactly what I was explaining over there. So I said we have y is equals to x, we have y is equals to mx, we have y is equals to mx plus c. Baby stage, teenager, and adult. So if you are given a straight line in a form of a formula, considering that first one, then I know this is at a baby stage, which means on a Cartesian plane, you must know what is a Cartesian plane. So on a Cartesian plane, let's say this is x, this is y. So I'm going to draw each of these functions just as an estimation, and from there I'm going to give them some names. So let's see. If we've got y is equals to x, which means if x is equals to 1, also y must be equals to 1. If x is equals to 2, also that must be equals to that. If x is equals to -1, also y must be -1. -2, -2, -3, -3, -4, -4, 3, 3, 4, 4. So that is what is meant by the graph of y is equals to x. It means whatever x value, it's equals to whatever y value. Whatever y value is equals to whatever that. So you just have that point, that point, that point, and that point over there. So you can just connect the dots, guys. You don't only connect the dots if someone wants to rob you, but you also do the same with the functions, ladies and gentlemen. What do? You connect the dots. So let me see who is in this lesson. I see Tando over there. So Tando, I'm going to name this function t of x. Very, very much important, ladies and gentlemen. So why am I having this line in that direction and not in that direction? Is because I've got a positive value over there. So that means you can either have y is equals to -x or y is equals to x. So that means if I had y is equals to -x, it was just going to be the same thing, but in that direction. Very, very much important, ladies and gentlemen. So now let's have a look at that one. Can you see? I've got m. What does m mean? It represents the gradient. So that means the gradient in this case, it's now 2. So when it's 2, it means the graph is a little bit steeper. So that function now, it means if x, for example, is 1, so inside the brackets, if you say 2 times 1, then y is 2. So x is 1, y is 2, is that point over there. If x is 2, then it's more like you substitute with 2 there, then it's 2 times 2, then it's 4. That means where x is 2, y is 4. Then also on this side, if x is -1, it's like -1 times that, y, it becomes -2. Then you also do the same for -2, then it becomes -4. Let's see, -4. So it can continue up to infinity. But notice something, guys. Also, that same function, it passes through the origin. I'm going to answer this question of why is it passing through the origin. It is because, ladies and gentlemen, there is no vertical shift. It's just the gradient over there. And remember, guys, on that function of y is equals to x, there's an invisible 1 over there, which it's not necessary to write. I'm just not sure of how many of you guys in this group speak Bedi. But my teachers used to say, if they send you to go buy bread and you just come across, let's say, one goat, and they say, what did you meet on your way to the shop? You wouldn't bother yourself to say, gogo, ngihlangane nembuzi eyodwa. No. You just say, ngihlangene nembuzi. I'm not sure if I'm calling it correctly, guys, but in Pedi, if you go to, let's say you go to, okay, let's go to the shop again, guys, because there's nowhere else we can go. In our village, we just have home, school, and shop. So you go to the shop and you meet one person and they say, how many people did you come across? Guys, I wouldn't bother to say ke tlhakane le one motho. You will just say ke tlhakane le motho. So in short, Shreyas, what I'm saying is when you go to the shop and you come across, let's say, one person, when you come back, you wouldn't bother to say I came across one person. You will just say a person. So that is the reason why, for example, if we have y is equals to x, there is no need for us to write that one over there. We just know that one is there even though it's invisible. So you just say y is equals to x, just like maybe when you say 2p minus, let's say, c is equals to 0. So as an example, you know there is 1c, but it's not necessary for you to write that one over there. So that is the reason why at all times it's not necessary to mention or write that one. So good people, I just wanted to put a sense in your mind in terms of why we have one over there, but it's not necessary to write. I try to explain in Zulu. I'm not sure in Venda, what would one say in Venda? Ndotangana na muntu. There's no need to say ndotangana na muntu nakuthi. Guys, what am I saying? It's fine. Guys, if you don't get it, forget about it. So, good people, what am I saying? I'm saying in this case, the slope is no longer 1, but is 2. So that is why this straight line, of which I'm going to call it Lindo, but let's call it L of x, it is sloping at, most importantly, guys, we know very well that the gradient for this line is actually a positive gradient because it's passing from that quadrant number 1 and quadrant number 3, same as that one for Tando. So now let's have a look at that one. So I think I've done that one over there. So let's have a look at this one. Most importantly, guys, you firstly need to check if your sign is positive or negative. But because it's negative, it means that straight line is going to be passing through quadrant number 2 and quadrant number 4. Why? It's because the gradient is negative. Ladies and gentlemen, the slope has to match that of -4. Very, very much important, ladies and gentlemen. So that means, in short, where let's say x is 1, that means the y value, you just substitute with 1 there, then the y value is going to be -4. So where that is 1, you are going to have -1, 2, 3, 4. You are going to have a point over there, which means same applies. If there you've got -1 and you substitute it there, you're going to have +4. 1, 2, 3, 4, where x is that. Can you see the slope, guys? The slope of -4 is steep, and it's very, very steep, guys. It's a mountain that you wouldn't easily climb. So let's call this one, let me see, I see Minentle there. So this one, I'm going to call it M, which means this is M of X. So can you see, guys, these names, these letters are just given, but let me not give it M because it's going to be confused with M for the gradient. Let me see. I've got Gaugelo. I'm not sure if it's Gaugelo or Gaugelo, but whoever it is, let's just give it K and say this is K of X. So can you see the graph of Tando? It's not that steep. So this is Tando. No, Tando is this one with a positive. So this is the graph of Tando, and this is the graph of who? This is the graph of L, and this is the graph of Gaugelo. So can you see the graph of Gaugelo is in the negative slope, and most importantly, it's so steep. What makes it to be steep is because of that value of -4. Very, very much important, guys. The graph of Tando, it is not that steep compared to the graph of Lindo, because for this one the slope is that invisible 1, but for this one you've got 2 over there. Let's see. Let me now try to sketch that one. Guys, my name is Desmond. I'm going to call this one a D, which means this is D of X. Good people, the difference there you can see. This was at a baby stage, what is it? Teenager, a teenager. So now I'm dealing with an adult. So can you see the difference between those? Here you've got positive 2. Remember, guys, I said this talks about the vertical shift. If it's a plus, then it means vertically. For someone who wears a suit, when they go to school, they are going to say vertically it moves either upwards or downwards. But for us who wears vests to go to school, we just say it will vertically move either upwards or downwards. So guys, I went to those schools where it was difficult, so I was wearing a vest. So I used to say this actually influenced the vertical shift. So because it's a plus, then that means it is going to move vertically upwards by 2 units from the origin. So it's either it's a function at that angle or at that angle, or at that slope or at that slope. So how do I know in which slope? This is going to tell me, guys, if it's a positive, then it is like that. If it's negative, it is like that. Very, very much important, ladies and gentlemen. So that means now, because the slope is 3, I know if it's 3, it's going to be steeper, guys. It's going to be steeper than that one, which is 2. Remember, the slope for this one is that invisible 1. For this one is 2. Let's see. For this one now is 3. So it's going to be passing somewhere there. But because there's a vertical shift of +2, that means that straight line is going to move by 1, 2. So possibly that function, it will be something similar to that. Very, very much important, ladies and gentlemen. So this is d of x. Guys, I hope that makes sense. So let's now quickly move to that one. So that one, can you see the gradient is negative? What does it mean? It means it's going to be in that direction. And again, the slope is -2. So it might not really be that steep. Where x is -1, that is going to be that. Where x is +1, it's going to be that. Where x is 2, where x is that. So you are going to have a straight line like that. But be careful, guys. It is that straight line which was passing through the origin. But now, can you see? It has been moved by 3 units downwards. So that means it is going to cut that y-axis at 1, 2, 3. So it's going to pass there in the same slope of 2. So it is going to move 1, 2, 3. So that means, ladies and gentlemen, 1, 2, 3, it is possibly going to do something similar to that. And this one, let me call it, I see Refilwe there. So this is Refilwe of X. Massively important, ladies and gentlemen, that you are aware that these letters are just given to, they just represent the names of this function. So what I'm going to quickly do is to remove all of this. So remember, guys, just in case if you are not writing any notes, this lesson is being recorded. I'm going to make sure that I post it tomorrow, so that in case if you got confused somewhere, you will be able to just view the lesson again. And most importantly, towards the end of this lesson, I'm going to give you guys an opportunity to ask questions. So just make sure that in case if you've got any question, write it down. I'll open some space where you guys ask some questions. But for now, let me do the presentation in peace. All you can do is just to have a sip of, if you've got a glass of water there, just have a sip. Good people, I'm going to be very quick on this one because I've explained in detail so that you've got a background. I said functions straight line are normally given names. It could be g of x, it could be h of x, it could be f of x, it could be k of x. Guys, that song of Mapiano, it's going to be released very soon. I just need someone who's good with the beats to just do those gong things over there. I'm sure it's going to be a hit, ladies and gentlemen. End of the year. So, guys, this is like Lindo of X, Desmond of X, Howell of X, whatever. So, the general formula of a straight line, the general formula, because now we are not at a baby phase, we are not at a teenager stage, but let's consider ourselves being adults. Why? Because we already understand that we have y, which is equals to m being the gradient, x plus c. So let's take this as the general formula for a straight line. Very, very much important, ladies and gentlemen. So now you know very well that the y, it talks about that vertical y, and the x is the x. Then m is the gradient or the slope, and then c, it represents the vertical shift. For you not to forget in terms of the slope being negative or positive, just think of a mountain, guys. Just think of a mountain. Think of yourself walking from this side towards the east. We know very well that towards the east, normally on a Cartesian plane, east is taken as positive. So that is the reason why from that point to that point, we are going to have a positive gradient. Think of yourself walking from right to left. So that means you are heading towards the west, of which we know very well that on a Cartesian plane, we know on this side we've got the positive values and the negative values. So you walking from there to there, it means you are actually walking towards the negative. That is the reason why for a line, a straight line with a point there, straight up to maybe a point somewhere there, or continuing that direction, we've got negative gradient. So this is just for positive and negative. In terms of how steep it is determined by that value being maybe positive 2, positive 1, negative 3, negative 7, whatever. That means that mountain, instead of it being that steep, it could be something similar to that. If the slope or the gradient is not that steep, it's going to be something similar to that. But most importantly, just be aware that when you talk about m, we refer to the slope. Good people, in short, m is the gradient. So we do have a formula for the gradient, which is change in y over change in x. What does change mean? Change means this 2 minus the same thing 1. So that means it's y2 minus y1 over x2 minus x1. So that means if we get to a stage where we need to calculate the gradient of a line, we must have two things, guys. You need y2 and y1. What does it mean? It means you need 2 points. For those of you who are writing notes, so it means generally you need 2 points. What do you need 2 points for? For when you calculate the gradient. Very, very much important, ladies. So now let's talk a little bit about C. What does C do? So C, it actually represents the vertical shift. So the moment we talk about C, guys, we think about the vertical shift. The word vertical, it means up or down. The word horizontal, that's when we talk about left or right. So when I say vertical, do not assume I'm talking about upward. Vertical is either up or down. So how do you see it's up? That's if your C value is positive. How do you see if your C is down? That's if your C is negative. Massively, 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 massively important, ladies and gentlemen, that you fully understand what I'm trying to explain over there. So in short, good people, that means uh, when the general formula is y, it doesn't matter if the gradient is represented by a, it doesn't matter at school if they represent that c value as q. But what matters the most is for you to know that there, good people, we talk about the slope. Very, very much important, ladies and gentlemen. There, we talk about vertical shift. So, guys, it's very, very much important that you fully understand that part. And most importantly, remember, you can either have a positive or a negative slope. You can either have a positive or a negative shift. Massively important that you fully understand those. Then, in short, guys, you can have a Cartesian plane similar to that, where you've got the x and the y-axis. So, for a line crossing like that, good people, that means there we've got positive gradient. Ladies and gentlemen, for that one, we are going to have negative gradient. So because we have more than one line, we can therefore give it name and say this is G and this is France. So this is George, this is France. Massively important, guys. It doesn't matter whether the graph has shifted either upwards or downwards. Maybe you have something similar to that, but what matters the most is that for that one, maybe a h of x, it has a positive gradient. Maybe for that one in that direction, which could be what, which could be k of x, it has a negative um, gradient. So guys, what I've explained up to this point, it's all that has to do with a straight line. So as I'm about to conclude on a straight line function, I want you guys to be aware that normally when we're dealing with straight lines, it's either they want you to plot. If they don't want you to plot, they are going to plot and say, give us an equation of a straight line. So consider yourself very, very lucky if you joined today's lesson, because when we get to that stage where we solve exam type of questions, you will fully understand what it's meant by a straight line, and again how to use today's information to answer questions related to a straight line. So good people, before I move to the next part of our lesson for today, is there someone who's got a question, or otherwise did you all understand and are you all happy with what I've explained up to this point? Remember, unmute your mic, make a comment, mute your mic.
No questions, sir.
We find
No questions, sir.
No questions, sir.
Okay, seems like we are all on the same page. So I'm just going to remove all of that and try to explain all that you need to know regarding what we call parabola. Let's see. Parabola is the type of a function that we will be talking about. Massively important, guys. It's just a name, guys. You know that a truck is it looks different from maybe a sedan or a private car or maybe a taxi. So we have dealt with a taxi. We are now looking at a truck, guys. At all times, functions are given names. It could be g of x, it could be f of x, it could be h of x, it could be whatever there. We just know that all of this is actually the same as y is equals to whatever the type of the function. So just a quick recap, guys. Remember, we said a straight line is y is equals to mx plus c. How do you recognize a straight line? That's when you don't have any power there. So this is just x to the power invisible 1. But the moment you have maybe y is equals to whatever, then you have x to the power 2. That makes it a parabola. So that is the difference between a straight line and a parabola. Massively important, guys, that you are able to notice the difference between a straight line and a parabola. So good people, also here we've got faces. So let's say a parabola, initially it was something as y is equals to x squared. Very, very much important, ladies and gentlemen. So again, we draw functions on a Cartesian plane. So that means all of these functions, guys, will be drawn on a Cartesian plane. Massively important. So an interesting thing about a parabola is that it's either you have it in that shape or you have it in that shape. So that is what is interesting about a parabola. So that means, ladies and gentlemen, for that one like that, and again for that one like that, there's something which makes it to be either like that or like that. So let's see what makes it to look differently. It's because of the a value. So that means we have y is equals to a squared. So that a value, ladies and gentlemen, it influences the shape of a parabola, which means the a value can either be plus or it can be minus. So when you have a positive a value, that's when you have that type of a shape. When you have a negative a value, that's when you have that type of a shape. So because myself, ladies and gentlemen, I'm a slow learner, sometimes I forget these things. So I have to try and find a way in which I can remember these things. Good people, when my mood is positive, I'm happy. But when my mood is negative, I'm very sad, guys. So that means when we have a positive value, it means the mood is positive. Therefore, I'll be smiling the whole day. So this is that shape of the function. So for you to see that indeed I'll be smiling, ladies and gentlemen, that's when I draw. This is not me, guys. This is not how I look. Let me see in the group who looks like that. It's unfortunate. The person who looks like that, they didn't attend today's lesson. But on our next lesson, just remind me. I will show you guys who looks like that. So for someone who has got a negative mood, obviously they are going to be sad. So let me just write it there. So these are some of the tactics that you can use for you not to forget these things. So negative mood. So that means you will be sad. ladies and gentlemen. Die hele dag, which means the whole day. So this is how you look like when you are sad. I'm not sure if it's everyone who looks like that when they are sad, but this is how I look like when I'm sad. So, which means this is the shape of your parabola when you've got a negative a value there. For example, this one, it can be y is equals to maybe positive 2x squared. Can you see that 2 is a positive value? This one can be maybe y is equals to negative 3 over 4x squared. Can you see the a value is negative? Massively important. Massively important that you fully understand what I'm trying to explain over there. Good people, the formula for a parabola, it doesn't end there. It evolves. Just like in life sciences, they said in the olden days we were something else, and now we keep on evolving. I wonder how a person will look like in 1,000,000 years to come, because we keep on evolving, guys. So anyway, let's see. This formula, it is now y is equals to a, remember, positive or minus x squared. So we have again that plus q or c over there at all times in all of the functions, guys. That influences the vertical shift. The vertical shift. Ladies and gentlemen, it will vertically or vertically, whichever way you choose to pronounce it. They always say there is no master of pronunciation. Ladies and gentlemen, as long as you fully understand exactly what you're talking about, it will vertically shift either upwards or downwards. Obviously, you can imagine how it will look like when it shifts either vertically upwards or downwards. So the same thing at that shape, we just shift it either upwards or downwards. Can you see what happens? If we shift it upwards, let's say maybe by plus 2, by 2 units, then it shifts 1, 2. Then you have something similar to that. Can you see? But now, if we shift it downwards, maybe by negative 3, so it's going to be negative 1, negative 2, negative 3. So it's going to be something similar to that. Very, very much important. So now we were just talking about the vertical shift. Similarly, the same one for that set shape. It can be shifted downwards by 2 units, 1, 2 from the origin. Boom, 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 boom. Let's see. It can also be shifted vertically upwards, maybe by 3 units. So that means it could be, let's say, 2x squared plus 3. So boom, 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 boom. Guys, I hope it makes perfect sense. Good people, it doesn't end there. It keeps on evolving, this formula of ours. Let me just write it there. It keeps on evolving. When I say it keeps on evolving, Shriyas, you might find that in grade 10 you only focus on a parabola at that stage. When you get to grade 11, then it's an evolved one. When you get to grade 12, it's an evolved one. Good people, the reason why I call these master classes is because I do those chapters which are common in each and every class. In that way, I'm able to take you through the foundations of this chapter. So if you're in grade 12 and you notice that I'll be doing a grade 11 or grade 12 lesson. If you are struggling with that chapter, make sure to attend, because, ladies and gentlemen, please do allow me to say, a day without learning something new, it's a day wasted. By so saying, please make sure that by the end of each and every lesson that I conduct, you learn something new. So That is why I'm saying at all times, in all of my lessons, you will be learning something new. Very, very much important. So now let's continue with that formula. It doesn't end there, Tanya. It continues. You can have, let's say, ax squared. So in between, there could be plus bx. And again, they can add a c over there. So at this point in time, you know very well that the a value has impact on the shape. Not necessarily the shape, but let's say the mood of our function. So in our upcoming lessons, when I say what is the mood of that function, you just say happy. When I say why happy, you say because the a value is positive. Why that one like that? The mood is negative, or the mood is sad because the a value is negative. So that means if maybe we have, let's say, positive 2 there, you might find that maybe a function of a parabola is like that. Maybe when it's positive, let's say 4, you might find that maybe it gets wider or narrower. That's something you can investigate by testing different functions. Maybe when you sketch for, let's say, positive x squared, you might find that it gets even more wider or maybe narrow, whatever the case may be. So you now know the influence of that a in terms of the sign being positive or negative. Then, ladies and gentlemen, I've explained that q. So that q is the same as that c over there, which influence, Tanya, the vertical shift. Massively important, ladies and gentlemen, that at all times you are aware that this influence the vertical shift. So you now know that if we have positive maybe 2 shifted upwards by 2 units, if it's negative 7 shifted downwards by 7 units. But now what about that plus v? So these are the type of questions that you should ask yourself as a grade 12 learner. These are the type of questions that you should ask yourself as a learner who's upgrading their mathematics. So, ladies and gentlemen, you might find that this one, it actually influences the horizontal shift, which is something that you could also investigate by trying to plot different types of parabola. So what I mean by that is you might find that that p value, maybe you end up having a graph but shifted towards the left, or maybe a graph shifted towards the right, or maybe that one shifted towards the left, towards the right. And also it can still shift upwards and again sideways, which means it could be now something similar to that, or otherwise something similar to that. Ladies and gentlemen, it's very, very much important that at all times, when you watch or when you watch this lesson again, you don't get confused by all that I'm doing over there. This represents different types of functions, ladies and gentlemen, so do not get confused. And there is something very interesting about a parabola, ladies and gentlemen. So a parabola similar to that one, it has the following. It has the x-intercept. The x-intercept, that's where that parabola touches that x-axis. And again, ladies and gentlemen, it has the vertical shift. So that point is what we call the vertical shift, influenced by that. Good people, it also has a turning point. A turning point, in short, refers to as TP. So this formula of a parabola, Shreyas, it doesn't end there. You know, this one, it keeps on evolving, while the others they don't evolve that much. So you can have something similar to that. Let's say squared over there and then plus q. So I think only the grade 12s they use this formula, where this is the x value for the turning point, and this is the y value for the turning point. But for the sake of being on the same page, for today's lesson, I won't include that one. So when I solve exam type of questions, I'm going to indicate to say the question paper that will be dealing on that particular lesson, it's only for grade either 11 and 10 or grade 12 and grade 11 learners. So a masterclass means everyone is invited, but when we solve exam problems, I'm going to indicate to say only grade 11s and 12 are invited, or only grade 10s are invited. So for those of you who are new, don't get surprised. And remember, guys, before I forget, I do have private lessons. So in those lessons, that's where I do one-on-one lessons only on weekends. So during weekdays, I do master classes. On weekends, it's either you enjoyed this lesson but you forgot all of this and you don't want to catch up, because I'm going to post all of this lesson on my website so you can catch up. In case if you don't want to catch up because you wouldn't be able to ask some more questions, then you can request for that one-on-one lesson. All the information is in the group. So after this lesson, I'm going to pin a message for those of you who deleted it. So in the group, click on that message at the top which is pinned, which says click this pinned message. That's where you will find all the latest information in terms of my lessons, how I operate, group rules, tips, and everything. So ladies and gentlemen, in today's lesson, I think I'm only covering a straight line and a parabola. So I'm going to remove all of this just so that I include the other part of this function being a parabola. So let me just write the general formula that says ax squared, let's say maybe plus c over the. So what I want to explain, guys, these are some important stuff. So I've said we have what we call a parabola that is formed by that shape, a sad and a smiling shape. And again, we have what we call axis of symmetry. What does axis of symmetry do to a parabola? It's more like it cuts it into half. So if you have a slice of bread, something similar to that. This is a slice of bread, guys. I'm not sure if this is then going to be a white or a brown bread. But whatever the color is, because I know we have some yellow slices of bread. I just haven't seen pink. I'm not sure about black. I'm not sure about green, ladies and gentlemen. If there's someone who knows how to bake a green bread, please share with us the recipe, ladies and gentlemen, so that we can also enjoy the green bread. Okay, so guys, when we talk about the axis of symmetry, this is what you always do with your little sister, with your little brother, so that you equally share the bread. You cut it into equal half so that you don't fight. You can imagine what's going to happen if this slice of bread is cut somewhere there and someone has to take this portion and the other one has to take this portion. I'm telling you, there's going to be a Jackie China movie at home. Something will be flying. Someone will be throwing some whatever, fighting because of unequal slices of bread. So, good people, for us not to fight because of unequal pieces of this slice of bread, you need to cut it into equal halves. So this line, which we call a malamulela, ladies and gentlemen, we used to call this line malamulela because it lamula the conflicts. So this line is what they call axis of symmetry, but at home we used to call it malamulela. So malamulela, guys, is axis of symmetry. Axis of symmetry. I'm sure you will never forget that axis of symmetry cuts whatever into half. But because now we are dealing with a type of a function called parabola, so that means if we have a Cartesian plane over there and we have a parabola, something similar to that, good people, where will the axis of symmetry be? It has to cut that function of f into two equal halves. You know very well that if you can cut it there, you are going to cause a fight. You will see Bruce Lee being Tanya and her little sister Renee flying some very massive kicks because of unequal halves. Good people, always the axis of symmetry passes through the turning point of a parabola. So if we have the axis of symmetry passing there, I'm telling you, no one is going to fight, guys. There's equal margarine there. There's equal margarine or peanut butter there. Ladies and gentlemen, during our time, we did not know what we call a peanut butter or a margarine. We just wanted it into equal halves, and then life goes on. So with you guys, you are fighting for the half and that portion of the peanut butter, guys. So just make sure that while you cut it into two equal halves, you remember that this is axis of symmetry. This is axis of symmetry. So for a parabola on that Cartesian plane similar to that, this is axis of symmetry, ladies and gentlemen, is represented by a dotted line. Massively, massively, massively important. So we say axis of symmetry, it actually splits a parabola into equal half or into half. So another point, axis of symmetry. For now, guys, you just need to be aware of these things. When we solve exam type of questions, that's when you will understand exactly what is meant by those. The other important thing with regards to a parabola is the turning point. Is the turning point. You know very well that you can either have that turning point or you can either have that turning point. A parabola cannot be something like that or like that, having that general formula. So it's like that or like that. So this is where we are going to have the axis of symmetry. Something interesting, guys. Curious in grade 10. If Mr. Kele has attended today's lesson, if a parabola, let's say maybe the turning point, it turns there along the y-axis, your axis of symmetry is within this y-axis. Why? Because this is the turning point of that, and we know that the axis of symmetry cuts the parabola into two equal halves. So if the turning point is there, then the axis of symmetry is within the x-axis. Massively important, ladies and gentlemen, that you fully understand all of this information. So guys, please make sure that you listen very carefully and make sure that you don't stress yourself about having to squeeze everything in your small anyana head. It is going to make sense as we continue. And most importantly, guys, a parabola has got the x and the y intercept. intercepts. Intercepts. Very, very much. What are these things, guys? Obviously, we draw functions on a straight line. So the x-intercepts, the word intercepts means touching. Intercepts, let's say maybe touching, or maybe where it cuts. So that means a parabola can have the x cut, or it can touch the x axis. So for a parabola similar to that, can you see it touches the x intercepts there and there? So that means it has two x intercepts, and again you can see it touches the y intercept or the y axis there. So that means you can see it touches the y axis there at that point. And most importantly, you know this is the turning point, which we call a TP. So what else do we have on a parabola? We know we've got the axis of symmetry, malamulela, batho ba bantle, malamulela. I don't know what we call that in Venda. I'm not sure if there's someone attended this lesson who's in Venda who can assist me in terms of the relevant word for malamulela. But ladies and gentlemen, I hope you fully understood when I used the word axis of symmetry. I'm not sure that friend of mine has attended today's lesson, but he was going to tell you that if you don't get it, forget about it. So, ladies and gentlemen, that's all 1, 2, 3, 4 that I wanted you guys to be aware of. So, good people, it seems like we have reached the end of our lesson for today, which means when we proceed tomorrow, that's when we'll be looking at a hyperbola and an exponential. From there, good people, probably from Wednesday day, that's when we'll be looking at solving exam papers, which is the name of my YouTube channel, my Facebook page, Instagram, Twitter, and guys, we are also on TikTok. Good people, website is solving exam papers. So just in case if you want to check out our other social media platforms, you can just use that handle over there, which is solving exam papers, which is what we'll be doing starting from Wednesday. Good people, are you happy with today's lesson, especially those who are attending my lesson for the very first time? How did you guys find my lesson for today?
The lesson was nice. Like, at least I could remember most of the stuff I learned in grade 10, which I'm doing right now in metric. So it's actually more straightforward. Like, tomorrow I'm writing a test. It was very
Tanya, thanks for that feedback. Guys, Ferdinand, I like that voice note that he said. He mentioned something that has the word dope. So it's more like, in short, today's lesson, guys, it was dope. Ferdinand, are you there to just conclude today's lesson by just saying the lesson was dope? Are you there? Let me look. Let me check. Let me see who has attended. Tebogo Puti, are you happy there? Renailo Lubisi, are you happy there? Minentle Dlamini, are you happy there? Tando Mabona, Tando, how is it going there? Grace Makito, Tumelo Janifa, Young W, Nduna, Bonduna, Paramin, Kunjani Lapo, Zbal. Timakazi Mufokeng, Xoliso Mhlongo, Hayi nami ngiyaphila. Determination Kile, Shuyas, Zandile, Tibaso, Kevin,
The
Mr.
lesson was
D.
like, it was like a really great year.
The
Koka
lesson was
sekare
good, sir.
ile ntswembu.
Nele Ntswembu, Nele Tope.
Ine ile dope. Ile
Nele Tope.
ntswembu. Yeah.
Where's Mr. Tope? I'm trying to search for Mr. Tope. Ferdinand, are you there?
Minere, lesson e ne le sharpo, e ne le dope, lesedi le tlile yaanong ke itumetse.
Tope. Molebogeng, are you there? Where's Lerato?
She's present.
Mr. Tele, are you good there? Khululekani hlophe kunjani lapho ntombi enhle kunjani. Let's see. Who else? Tebogo Puti, how is it going there? I don't think you've said a word. Let's see. Okay, so guys, this brings us to the end of our lesson for today, unless if there's someone who's got a question, but I hope all was clear, guys. No questions, guys, before I close the lesson.
No questions, sir. Everything was straight and forward.
100%. So,
no questions, sir.
Khululekani hlophe. I had your mic muted because it was unmuted, so it was causing a disturbance in the background. So that was the reason why I had your mic muted. So just make sure that next time when you join the lesson, you just join and have your mic muted. So my apology in case if you wanted to communicate throughout the lesson, but you couldn't communicate. It was for that reason that we wish for all the mics to be muted. Did you understand, Khululekani?
Yeah, I do understand, sir.
Okay, 100%. So guys, thanks very much for joining. My name is Desmond. Have a good night, and I'm out.
Thank you, sir.
Is that good night?